Lesson 5 is on rational expressions. Rational expressions are any algebraic expression that can be written as the quotient of two polynomials. So it sounds confusing, but the word quotient just means a fraction. And that fraction has polynomials in the numerator and the denominator. So we're looking at terms with variable parts and coefficients. And sometimes how we're going to simplify these is that we may need to factor. So the reason we're practicing factoring, and factoring is a really important skill, it pops up as a way to simplify in many different units that we're going to look at. So once the rational expression has been factored completely, got to factor completely, we can divide common factors from the top and the bottom, so from the numerator and the denominator. So this first one doesn't have any factoring really, but I know that I can divide my coefficients. Negative 28 divided by 7, is negative 4. And then if I divide the m's, if I had 3 in the numerator and 1 in the denominator, this one would cancel and I'd be left with just 2. So I have m squared. So that would just be my answer. When I look at something like this, it's a little different. When you have a denominator of negative 6m, I guess you could look at dividing the first term by that denominator and then dividing the second term by that denominator. But another way to approach this would be to factor. So if you see a common factor in the numerator, I could divide both of those terms by 12m. That's my common factor. I'd be left with n minus 2. And then in the denominator, I have negative 6m. So that might help a little bit. I'm trying to simplify this as much as I can. I do want to factor if I can. So when I look at that one, 12m divided by negative 6m, that's negative 2. And then I would be left with n minus 2. So it's in factored form. It's as simplified as I can make it. The fact is I was going to have two terms in my answer, so I factor them to show my simplest form of my answer. So this one over here, a little different. I have two terms in the denominator, only one in the numerator. But what I would like you to do is to factor first. Oh gosh, that's going to be huge. So you have to factor first. So we're going to see lessons 5, 6, and 7. In this unit, that's going to be a really important thing that you always factor first. So I do see in the denominator, I have a common factor of 5a. And what would be left would be 5a minus 2. So how does that help? Well, now I notice that my 5's would divide out and become 1. I have a to the third, so I have 3 a's in the numerator and this 1 here in the denominator. So if I imagine those canceling out, I would still have a squared in the numerator, and I have 5a minus 2 in the denominator. Since I can't factor this any further, that's it, it's done. So over here, I think, okay, factor the numerator. I can divide both terms by 5a squared. I'm left with a plus 6. In the denominator, I can divide both of those terms by 15, so 15a. And what I'm left with is a plus 6. Oh, this is exciting. I can actually cancel, because this is all multiplication in the numerator and the denominator, I can cancel these out. I can also imagine in my fraction, I have more a's in the numerator than the denominator. So when I divide, I'm still going to have an a in the numerator. 5 over 15, that's the same thing as 1/3. I could write the 1, but a over 3 is my simplified answer. Looks a lot more simple than what I started with. So factoring is going to help. When I look at this one, it looks kind of crazy. There's a lot of variables here, but I can divide the entire numerator by 7y to the third, because they all have 7, they all have y to the third. I'd be left with this one. I'd be left with 2 minus 35 divided by 7 is 5. Y to the third is divided out, so I'm still left with a W. 7 divided by 7, and then y to the third, and I'd be left with a Z. And then in the denominator, so I take my greatest common factor. Oh, I can't divide by a coefficient. I can't divide by any of these numbers because 2 doesn't divide into the rest. But all the terms have a y squared. So I'll divide them all by y squared. I'm doing it this way because my rule is that I always factor first. What I'm left with is 2 minus 5w plus z. Because all I did, I took a y squared out of all of those terms. These brackets are the same. So since this is multiplication, they can cancel out. What I'm left with, I definitely have 7. It'd be 7 over 1, I guess. Y to the third, y squared, I have an extra y in the numerator. So my simplified answer is just 7y. This one, I can divide the top, the numerator, by 5. I kind of like this because it's fun if things cancel out. I can divide the denominators both by 3. Look at that. They cancel. They're kind of designed that way. And I get 5/3.